Between 2026 and 2031, building the hardware and data centers necessary for the AI boom is projected to cost $7.6 trillion. This scale of investment puts a financial strain on the industry that exceeds the capital requirements of the dot-com and smartphone eras combined. To meet these requirements, companies are being forced to liquidate their established business units. High-margin legacy divisions are being treated as capital reserves to be drained and reallocated to the AI frontlines. Microsoft is currently cutting 4,800 jobs, with its Xbox division losing 20% of its staff through 2027. Newly appointed CEO Asha Sharma admitted the gaming business is losing 64 cents for every dollar invested, leading the company to spin out or shutter creative studios like Arcane and Ninja Theory to reclaim that capital. These cuts suggest that growth in the current market requires a significant reduction in traditional operations. When even the largest tech giants cannot maintain their historic footprint while funding AI, the focus shifts from general expansion to corporate survival. The battle for infrastructure has moved into low Earth orbit. Amazon is spending $82 billion on its LEO project, intending to launch over 7,700 satellites to compete directly with Starlink for global internet dominance. This rapid expansion is creating a logistical bottleneck in orbit. Earlier this year, SpaceX brought 260 Starlink satellites out of orbit to burn up in the atmosphere just to clear space for the next generation of hardware. To recoup these orbital costs, Amazon is bypassing the residential market and moving directly into commercial aviation. They have already secured multi-year contracts with JetBlue in 2027 and Delta in 2028 to provide in-flight connectivity. As the physical infrastructure of the internet becomes increasingly expensive to launch and maintain, tech companies are having to engineer new financial systems to sustain the buildout. Computing power is currently being transformed into a globally traded commodity. Because the hardware required to run AI models is scarce and expensive, it is now traded with the same financial scrutiny as raw energy. This chart shows how quickly a $100 million cluster of chips loses its value. An 18-month window is often enough for a new generation of hardware to make existing systems obsolete. The startup Ornn is now building a marketplace to trade this compute via futures contracts, allowing buyers to hedge against that rapid depreciation. By integrating with Bloomberg terminals, this system allows Wall Street to track and lock in prices for digital capacity in the same way they trade barrels of crude oil. AI has shifted from a software product into a foundational macroeconomic asset. Managing it now requires the exact same level of financial engineering once reserved for the global energy market. Nvidia has begun acting as a primary lender to the industry. Through a new program, they are providing AI startups with thousands of Blackwell chips with no upfront bill. In exchange for the hardware, Nvidia takes a percentage of the revenue those chips earn. They also guarantee to buy back any capacity that sits idle, creating a closed loop that keeps their customers locked into the Nvidia ecosystem. This resembles the lending practices seen during the dot-com era, where hardware companies like Lucent and Nortel lent billions to their own customers to buy their equipment. When those customers folded, up to 80% of those loans were never repaid. With trillions of dollars moving in these loops, the pressure to maintain growth is pushing competitors to abandon traditional market ethics. The financial stakes of the AI race have led to documented instances of corporate sabotage. A program codenamed CANS revealed that Meta hired hundreds of contractors to pose as teenagers on rival platforms. These contractors used under-18 accounts to flood models from OpenAI and Google with prompts about self-harm and eating disorders, attempting to force the rival AI to bypass its safety guardrails. In China, Alibaba has barred its 124,000 employees from using Anthropic's Claude AI. The company labeled it high-risk software after a security audit found hidden code within the tool. Anthropic confirmed they had bugged their own software to catch data siphoning. They embedded a look-alike character in the text that tracked whether the user was located in a Chinese AI lab, creating an invisible marker that reported back to their headquarters. The industry standard for tech competition has shifted toward these covert tactics, using digital spoofing and traps to protect market share. Beyond human sabotage, security researchers are beginning to find instances of AI systems operating without direct human control. A security firm called Sysdig recently identified Jade Puffer, an AI ransomware agent that executed an entire attack sequence, from the initial breach to database destruction, without a human at the controls. This timeline shows the agent entering through a known flaw and encrypting 1,342 production server entries. Its autonomy was clear after a failed login. The agent diagnosed the error, deleted the broken account, and built a working admin account in 31 seconds. In response to these complex digital threats, a market is emerging for highly restricted hardware. Lenovo recently launched a $44 student phone that removes internet capabilities, stripping the device down to basic calls and an AI button for schoolwork help. As the tech industry navigates autonomous threats and aggressive corporate maneuvers, the value of dumb hardware is rising. In 2026, the ability to disconnect from the AI frontier is becoming a primary feature for the modern consumer.